Okay, in the last class I wasn't particularly with it and I kind of apologize. We want to get the formula for the Laplace transform of the second derivative of a function. And of course that is the Laplace transform for the derivative of the first derivative. So we could write this then, and what I wrote last time would have worked, but it was way too complicated. And as I said, there's a much easier way. I knew that, and it just wasn't clicking for me. Okay, so we can say that this is this. So the Laplace transform of f double prime is the Laplace transform of f prime prime. So, well, we could write this as e to the negative st times the f double prime of t dt. But we could also write it as the integral of e to the negative st times f prime of t prime dt. And then we can write, well, we can use integration by parts. We let u equal e to the negative st and dv equal f prime of t prime dt. So that du, very familiarly, is negative 1 over s e to the negative st. Integrating the derivative of f prime of t, we find that v just equals f prime of t, so that our integral becomes what? It becomes uv, which is e to the negative st f prime of t evaluated from 0 to infinity, minus the integral of what? Well, going to be the integral of v du. Okay, well, the minus du is going to involve a negative 1 over s, so I can say that's, I'm going to have a plus 1 over s here, and then it's going to be times the integral from 0 to infinity of e to the negative st f prime of t dt. Now, if we simply recognize what we have here, the integral of e to the negative st f prime of t dt is just the Laplace transform of f of t. So we have here a 1 over s times the Laplace transform of f prime of t. And I think I said a dt there where it didn't belong, but you can check me out on this. Over here, at the limit infinity, as long as f prime of t doesn't grow faster than an exponential function, that is going to approach 0, and there are restrictions that we haven't really talked about on how fast these things can grow, because of course this product does have to approach 0 as t approaches infinity. But that happens, and what we get then is just negative, well, it's a negative of negative f prime of 0. Okay. Now, in a minute that's going to work out, but there's still something wrong. Okay, this never had a negative in it. Okay, so it's just negative f prime of 0. And then the Laplace transform of f prime of t we derived last time, okay, in a very similar manner. So we fill that in. It's going to be, and I'm still getting a 1 over s where I need to be getting an s, and I'm not sure. Okay, never mind. No, I mind. There's still something wrong here. This 1 over s is bothering me. But it certainly comes out of the du, and it doesn't come in here. So I'm questioning how I'm getting the s squared and the s. So I'm still a little bit confused. I'm going to think about this for a minute, because it has to come out here. And it does if you had an s here, but not if you have a 1 over s, because Laplace transform of, and this is Laplace transform of f of t, whatever was infesting my brain on Tuesday apparently has decided to revisit it. Been doing pretty well today. Just bad writing down. No, this is Laplace transform of f prime of t. I don't know what I'm thinking. That Laplace transform we derived before. It's going to be s, f of s, minus f of 0. And that's not what we get here. So I'm going to back up for a second and take another look at that 1 over s, kind of making an s out of myself here. And then we'll clean that up in just a minute.